Today we'll be looking at simplifying algebraic fractions. So in this case, right, we'll be looking at textbook page 150 and we'll be looking at 3 questions. Question 6b, 8a, 8d, and after that you'll be able to do all the questions on page 85 of question 3. So when they say simplify, it just means, right, you are dividing the common factors in the numerator and denominator in order to simplify it. So before we can go on to simplifying it, right, you have to let's do a quick recap on what are the special identity. So these are all the concepts you have learned in chapter 6. So you can see, right, chapters across each other, they are connected. So that's why you need to be firm up with chapter 6 before you can move on to this chapter 7. So special identity, there are 3 types. First one is a square plus 2ab plus b square. These are all your perfect square special identity. When you factorize it, it'll give you a plus b bracket squared. And the second one will be your a squared minus 2ab plus b squared. So when you factorize it, you will get a minus b bracket squared. And the last one, a squared minus b squared. This one is your difference of 2 squared. So when you factorize it, it will give you a plus b times a minus b. So now let's look at question 6b. So in this question over here, you can notice that the numerator can be factorized. And similarly for the denominator, it can also be factorized also. So for the numerator, you can recognize that it's in the form of a squared minus b squared. So my a will be equals to k. Use a different color. So in this case, right, my a is equals to my k, and my b is equals to 3. Because I know that 3 squared gives me 9. So when I factorize it, I will factorize into the special identity number 3. A plus b times a minus b. So my a will be k. So k plus 3 times k minus 3. So this is how I factorize the numerator. Now the denominator, right? This one will be your quadratic expression whereby you have a k square and a k in the middle and a number. So you have to use the multiplicative frame, which is your tic-tac-toe. Let me draw it out. Okay, so once I draw the tic-tac-toe, this one will be the times. The first term will be the something square, the variable square, and the last one will be the number. So k square, right, there's only one way to factorize it, which is k times k. Okay, so this means k times k give me k square. So now we need to factorize 12. So what are the possible pair of factors that we can have for 12? Let me write down. Okay, so after I write down the factors of 12, now I need to choose which one is the right pair of factors in order for me to get the right factorization. So in this case, I need to make sure that the pair of factors that I choose, it will give me, when they add up, they'll give me negative 7k. So first they have to multiply first. After that, these 2 boxes here, they will add up to 7k. So now I need to try to substitute value into these 2 boxes, which is the factors of 12. So in order to get 7, right? Okay, so how do I do it fast, right? Is that I need to consider what are the possible numbers, right? When I add them up together, they give me 7. So one of the numbers that I can see over here, right, it can be like 3 and 4. Because I know that 3 plus 4 is 7. So I will zoom in to this part over here. And I try to play with the factors in this region. So let's say, okay, so now, right, the next thing I look out for, right, is that this one is a negative 7k. There's a negative sign in front. Means, right, my factors that I choose at the start must have a negative sign in front also. That's why my answer will be negative 3, negative 4. So negative 4 times k, you give me negative 4k. Negative 3 times k will give me negative 3k. So when I add them up, it'll give me negative 7k. So I have write the right factors down. So now this one is just part 1 only. So my factors will be k minus 4 times k minus 3. So if you think that multiplicative frame is difficult, it's actually more than that. You have to use multiplicative frame, right, to chapter 7 in order for you to like simplify the expression. So if you can't get the multiplicative frame right, then you have issues simplifying these type of factors in this type of questions. So now I have factorized it into k minus 4 and k times k minus 3. Now I need to look out for common factors, and after that I just divide in the numerator and denominator. So I can see that the common factor will be k minus 3, divided by k minus 3, divided by k minus 3. And my final answer will be k plus 3 over k minus 4. So this is how I simplify this expression for question 6b. So now let's look at question 8a. It's similar also, just that now in this time, we are multiplying an additional fractions. So how do we do it? So first step is to factorize any quadratic terms that you can see or any square terms that you can see. So for example, the first part, a squared minus 4. So if I say, this a squared minus 4, right, it looks familiar somewhere. Oh, it's my difference of 2 squared. So my a will be equals to my a, and my b, right, b squared will be equals to 4. So in order to get b, right, it will be b equals to 2. Because I know 2 times 2 give me 4. So now I factorize it. So a plus 2 times a minus 2. So that will be the factorized form. So the remaining parts I just write back. Because the other fractions, right, there's nothing else for me to factorize further, so I just rewrite it back. So for the denominator, for the first fractions, you realize that there's a squared minus 3a plus 2. This one is your quadratic expression, and you need to use the multiplicative frame in order to factorize it. Okay, so now to factorize this quadratic expression, I will write down the terms a squared in the middle box and the number at the bottom right corner. And in order to know which pair of factors is the correct pair, I need to ensure that when I add up these two boxes here, it will give me negative 3a. So now, there's only two options for us to choose. So which one is the right choice for us to choose? So what do I do, right? I look that this one is the negative answers, and my a, right, they are all positive. So in order to get a negative terms to add up together to get negative answers, I have to choose the negative 1 times negative 2. So negative 1 times negative 2. So when you take negative 2 times a, it'll give you negative 2a. And a times negative 1 give you negative a. So negative 2a minus a will give you negative 3a. So my factorize, right, factors, it will be a minus 2 times a minus 1. So now we need to look at what are the common factors that we can divide in the numerator and denominator, and after that simplify it. So in this case, I realized that, oh, my numerator has a minus 2, so I can take a minus 2 divided by a minus 2 in the denominator as well. And after that, when you divide by both of them, you get 1. And then there's another one is a minus 1. I divide by a minus 1 in the numerator and denominator, because in the middle sign, right, is a times, so that's why I can just divide directly. So what are all my factors that are left behind, right? It will be a plus 2 in the numerator and 2 in the denominator. So this is my simplified expression. So now let's look at the last one, question 8d. So question 8d, right, You also make use of the special identity. It's just a time sign. So first step, we need to swap the fractions first. So u square minus v square, u square minus 2uv plus v square times uv plus v square over 1. So now I can factorize the numerator and the denominator in the first fraction. So I notice that it is similar to option number 3, which is the difference of 2 square for the numerator. So it will be u plus v times u minus v. And for the denominator, is of the form of the second one, the perfect square, which has a negative sign. So now right, the factors will be, okay, so basically right, for this case right, if you can just replace all the u and v right with a and b, then it is of the same form. So when I factorize it, it will just be u minus v bracket square. So when it's of the special identity form, you don't have to like do the multiplicative frame, which save you a lot of time. Times, okay, so for now for the second fraction, like we realize that actually there's a common factor between these two terms, uv and v. So uv is equals to u times v square equals to v times v. So you notice that the common factor will be v. So I pull out v as a common factor. And the factors that are not common, I'll just write it back. So v times u, give me uv plus v. So my factorized form will be v as a common factor being pulled out. And after that, I left with u plus v over 1. So now in this case, now I can just divide by any common factors. So I realize that there's a common factor of u minus v. So when I divide by u minus v in the numerator and denominator, I left with u minus v. Because there are like two sets of them. Since it's u minus v to the power of 2, means it's u minus v times u minus v. So once I divide u minus v in the numerator and denominator, I'm left with u plus v divided by u minus v. And the next one, right, you notice that you can combine the factors together. So when I simplify it, I just be u plus v squared times v over u minus v. So this one will be my simplified form. And this will be my answer. So you see, right, for this type of questions here, when you want to simplify it, you have to use special identity or multiplicative frame in order to factorize any quadratic expression before you can know what are the factors that you can divide in the numerator and denominator. So this is it. I'll reward you with a science pun because I'm running out of math pun. So I was reading this excellent book on anti-gravity and I find myself unable to put this book down. Okay, so I believe some of you can understand this one. And some of you who don't understand, you can actually ask your friend. So thank you.